Hello friends, today we are discussing about electromagnetic sensors, its principal working and its types. What do you mean by electromagnetic sensors? Up till now, we have seen different type of sensors, transducers, their types, their working principles. Today we are going to focus on the electromagnetic sensors. First of all, we should know the term electromagnetic. What do you mean by electromagnetic? Then we will see what is electromagnetic sensors. The term electromagnetic is nothing but it refers to any form of energy that is propagated as a wave. Because in electromagnetic sensors, electrical energy is propagated through the magnetic core. So these are called as electromagnetic sensors, in which the electromagnetic term is referred. An electromagnetic device, it is used to measure the physical quantities such as pressure or the loudness and convert it into the electronic signal of some kind. That can be a voltage. So these are called as electromagnetic sensors, where the electrical energy is converted into the magnetic one, where the magnetic core is used to deflect your action into the voltage, that are called as electromagnetic sensors. Now we can see there are some basic types of the electromagnetic sensors depending upon which quantity you have to measure. So if suppose we can measure the 3 or 4 basic electrical terms like resistor, conductor, voltage and the power. So if we have to measure the resistor, so for the measurement of the resistor there are two devices we have here. First is ohm meter and the multimeter. So how does this ohm meter work? What are the types of the ohm meter and what is this used for? Ohm meter is used for the measurement of the resistances. Second is the type of resistor that is called as multimeter. In the multimeter we can measure resistor, current, voltage. If suppose we have to measure the current, for the current measurement there are two types of the meters. First is galvanometer and the ammeter. Again these ammeters are having different types like AC ammeters and the DC ammeters, depending upon which type of current you have to measure, whether it is AC or DC. If you have to measure the AC current, then AC type of ammeters you have to use. If you have to use the DC current, then DC type of ammeters you have to use. Then third quantity, if suppose we have to measure the voltages. For the measurement of the voltages, there is voltmeter that we know that is very commonly used, and the other one is leaf electroscope. What is leaf electroscope? That we will see later. Now if suppose we have to measure the power, so for the power measurement we have the meter that is called as watt-hour meter. So these are the types of the electromagnetic sensors depending upon which type of quantity you have to measure, whether you have to measure resistor, current, voltage or power. So let's see one by one. Let us focus on the type of the quantity which have to measure, that is resistor. So let us see what are the electrical resistance sensors. So what do you mean by electrical resistance sensors? Electrical resistance and the electrical conductance sensors measure the resistance or the conductance of an electrical component or a system. So what does this electrical resistance sensor does? It measures the resistance or the conductance of the system. These electrical resistance and the conductance sensors are used in very wide variety of the industries across the board of the spectrum of applications, where we have to measure the resistance or the conductance of the electrical system. So first we have to focus on ohm meter. What do you mean by ohm meter? Ohm meter, it is an instrument which measures the resistance of the quantity. If suppose there is an electrical circuit and we have to measure the resistance across it, then we are going to use the ohm meter. Every device which is having resistance, it may be large or small, it may increase with the temperature for the conductor. However, for the semiconducting devices, the reverse is true. What is happening here? The resistance can be large or small, depending upon what? Depending upon the temperature. And if the temperature increases for the conductors, the resistance will increase. And for the semiconducting devices, if the temperature increases, the resistance will go decrease. So this is what the difference between the conductor and the semiconductors. Why we call these as the semiconductors? Because semiconductors can act as an insulator as well as conductors, depending upon what temperature we are giving them. And what are the examples of the semiconductor material? First one is silicon, which is very widely used, and second one is germanium. So silicon and the germanium are the semiconducting materials in which with the increase in the temperature, resistance decreases. Why? Because with the increase in the resistance, the movements of the electrons in the silicon and the germanium material will increase with increase in temperature. So if the movement of the electrons are increasing in the silicon and the germanium material, what is happening? The current starts flowing and the resistance starts decreasing. So this is what the basic difference between the semiconductor and the conductors. So we have to focus on what are the types of the ohm meters which we have to see. So generally there are three types of the ohm meter: series ohm meter, shunt ohm meter, and the multi-range ohm meter. So let us see one by one what are these series ohm meter, shunt ohm meter, and the multi-range ohm meter. So first of all, let us focus on the working principle of the ohm meter. So this circuit diagram shows the basic of the ohm meter. In this, what you can see, Rx, it is nothing but you can see these are the variable resistances which we have to measure. This Ra, it is the adjustable resistance, and it is the voltmeter or the battery, we can say battery we have given to the circuit. And through the point A and B, you can measure the whatever the resistance you have to measure. So this Rx is nothing but the unknown resistance which you have to measure. So let us focus on what is series ohm meter. So for the series ohm meter, let us see a small diagram over here. So for the series ohm meter, we can say this is the basic meter Rm. Now it is connected to the R1. Here the terminal A, this is Rx, and this is terminal B. So you can see over here, this Rx we have to measure, and this Rx is connected between A and B, and this is what the battery supply, and this is the R2. R2 we can say that this is the adjustable resistance over here. The current flowing is Im. This is I2. This is I1. So this Rx, we can say this is the unknown resistance. For this unknown resistance, we have to measure the value, and this type of ohm meter is called as series ohm meter. Why it is called as series ohm meter? Because in that basic meter is connected in series with the unknown resistance. So we have to measure this unknown resistance in series. So that's why it is called as series ohm meter. If we see the deflection plates, deflection of this series ohm meter, suppose it is giving the 100 degree of deflection, then at this left side you can see this is the infinite range, this is the zero range, and these are the ranges of the resistances. So in the series ohm meter, what we have to do is, if we are considering this R is equal to 0, resistance is equal to 0, then what will be the I? The current is large. As we know, resistance is inversely proportional to the current. So if we consider resistance is 0, then the current is large, so that the shunt resistance is, so if the R is equal to 0, I is equal to large, then we have to adjust the shunt resistance until the meter indicates the full deflection. So when the R is equal to 0, I must be large. So we are adjusting the deflecting plate at the pointer to show the full load condition. Now if suppose Rx is removed, this unknown resistance is removed from these two terminals, what will happen? The circuit is infinite and will show the no current to the pointer. Now we have seen the two conditions. When R is equal to 0, the resistance value is 0, then I must be large, that is current must be large, and it shows the full scale full load condition. And if R is equal to, or we can say when R is removed, when the resistance is removed, the circuit is infinite. And when the circuit is infinite, we can say no current is showing to the pointer, and pointer is at a infinite position. So there are two conditions. First is when R is equal to 0, current is large, and when the current is large, we can say the deflection or the pointer is at the 0. So we have seen two types here, or the two conditions. If resistance value is 0, then I is large, and when the current is large, it shows the deflection, full scale deflection of the needle towards the 0 sides, or we can say 0 marking of the deflection plate. And if resistance is removed from here, then the circuit is working as a infinite, and the deflection of the needle is showing towards the infinite. So we have seen the two conditions when resistance is 0 and when resistance is infinite. So this is the basic circuit diagram for the ohm meter. So what we have seen, the instrument is connected with a battery. You can see here the instrument is connected with a battery with the adjustable resistor over here, an instrument which gives the reading, and the resistance to be measured is connected across the terminal AB, and when the circuit is completed by the connecting output resistance, the circuit current flows and the deflection is measured. So we have seen the series type of ohm meter. So what is the condition? When the resistance to be measured is very high, then the current circuit of the circuit is very 0, and the reading of that instrument is assumed to be maximum resistance to be measured. And when the resistance to be measured is 0, the instrument reading is set to 0 position, which gives the 0 resistance that we have seen at the deflection plates. Next we have to see the shunt type of resistance or the shunt type of ohm meter. So in shunt type of ohm meter, what is happening? What is the difference between the series type of ohm meter and the shunt type of ohm meter circuit diagram is, as you can see here, this is the adjustable resistance, we can see R1, the current flowing is IM, and this is what the current meter. This is the switch, we can say this is the make break switch. This is terminal A, resistance Rx, and this is terminal B. Now previously we have seen the series ohm meter. This is the shunt ohm meter. So in shunt ohm meter, the ammeter is connected in shunt with the unknown resistor which we have to measure. So across this terminal AB we can measure the unknown resistance. So in this condition, in this shunt ohm meter, what is happening? If we consider Rx is equal to 0, the unknown resistance value, if we consider that is 0, the current will be 0. So current is showing 0 when the resistance is showing 0. Now what is the difference between the deflection plate of the series ohm meter and the shunt ohm meter? In shunt ohm meter, if we see the reading scale, this we can say this is the 100-degree deflection. Here it shows the infinite scale, here it shows the 0 scale. In the series ohm meter, what we have seen at this side, that is at the left side, there was a infinite deflection, and at the right side there was a 0 deflection. But in shunt ohm meter it is reversed. In shunt ohm meter, at this side, that is at the left side, you can see the 0 deflection, and at the right side you can see the infinite deflection of the pointer. So the first condition which we have seen, that is Rx is equal to 0. When the unknown resistance value is the 0, then current which is measured, that is 0. Now second condition is when Rx, that is unknown resistance, is infinite. When it becomes infinite, when we are removing that from the circuit. So when this Rx is equal to 0, the current passes through the battery, it shows the full scale deflection. So this is the basic difference between the shunt ohm meter and the series ohm meter. In series ohm meter, what we have seen, that at this left hand side it shows the infinite deflection, and at the right side it shows the 0 deflection. And in series ohm meter, what we have seen, when Rx is equal to 0, current is equal to 0, but which shows the full scale deflection. Now in this, when Rx is equal to infinite, that is unknown resistance is infinite, it shows the full scale deflection towards the infinite position. So this is all about the series ohm meter and the shunt ohm meter. Now we have to see the multi-range ohm meter. So let us see the multi-range ohm meter. So let us see what is multi-range ohm meter. So multi-range ohm meter is multi-range ohm meter. It is a device where you can measure the different variations of the resistances, different values of the resistances, by just putting the knob on the various range of the resistances. So these are called as multi-range ohm meter. So let us see the circuit diagram of the multi-range ohm meter. So in the multi-range ohm meter, again there is a adjustable resistor which is used in series with the ammeter, where at this side it shows the infinite deflection, here it shows the 0, and it is connected to the battery supply. We can say this is the battery supply, battery terminal T. Now we have to, because this is multi-range ohm meter, we have to select the ranges of the resistances. So we have the ranges of the resistances, like this is R, which is multiplied by 1. This resistance, in this the resistance is multiplied by 10. Now this resistance, this multiplied by 100, and this resistance which is multiplied by 10K. And you can say this is the range switch, and this range switch you can adjust. Okay, so this is the circuit diagram for the multi-range ohm meter. Now what is happening this multi-range ohm meter? As we can see, this resistance is connected with in series with the basic current meter, and it is given to the battery supply. So here we can see these 4 ranges of the resistances, where resistance is multiplied by 10 ohm resistance, where you can see the resistance is multiplied by 1, resistance is multiplied by 10, resistance is multiplied by 100, and the resistance is multiplied by 10K. Now what are these ranges? So if suppose I have to measure the values of the resistance below 1 ohm, so when I have to measure the values of the resistances which are less than 1 ohm, I am keeping this knob on the R multiplied by 1 range. So with that help, I can measure the values of the resistances which are less than 1 ohm. Likewise, if suppose I have to measure the resistances whose value is less than 10 ohm, then what I have to do? I have to keep this terminal on the R multiplied by 10 range. So this R multiplied by 10 indicates the range of the resistances, that is from 1 ohm to the 10 ohm. In this R multiplied by 100, it shows the values of the resistances from 10 ohm to 100 ohm. And R multiplied by 10K, here it shows the values of resistances from 100 ohm to 10 kilo ohms. So these are the ranges of the resistances which we can measure on the single ohm meter by selecting the range of the resistances. So by selecting the range of the resistances, you can measure the different value of the resistances. That's why it is called as multi-range ohm meter. So how does this multi-range ohm meter, or how the ohm meter works? So this ohm meter works on the D'Arsonval principle. These ohm meters works on the D'Arsonval principles. Now what do you mean by D'Arsonval principle? D'Arsonval principle basically used for the movement of the DC moving coil. For the DC measurement it is used. So what is D'Arsonval principle? D'Arsonval principle is basically used for the DC measurement. Now what is the basic principle of this D'Arsonval movement? So in the D'Arsonval movement, a DC coil which is placed in the permanent magnetic core. There is a DC coil which is connected to the spring. It is placed between a permanent magnetic core, and when the current flowing through the circuit, the moving coil or whatever the core is placed between the permanent magnet, the motion of that moving coil depends upon the proportional of the current. How much the current is flowing depend upon that the deflection of the core is depending. So in that permanent moving coil, the current which is present in the core, that will deflect the coil itself through the permanent moving coil and through the ranges of the values of the resistances. So this is related to the D'Arsonval principle. So these ohm meters works on the D'Arsonval principle, where the electromagnetic core is suspended between the poles of the permanent magnet. So there are permanent magnet poles, and in between that there is a magnetic core which is suspended and which shows the movement depending upon the current which is flowing through the core. So it is all about the D'Arsonval principle and the ohm meters. So we have seen series ohm meter, shunt ohm meter and the multi-range ohm meters. So we have seen the types of the ohm meter, that is series, shunt and the multi-range. Now in the previous slide what we have seen, the resistance sensor, it is of two types, that is ohm meter and the multimeter. Now let us discuss about the multimeter. So you can see the picture of the multimeter over here. So why it is called as multimeter? First of all, because in the multimeter we can measure the values of the current, voltage and the resistances. As you can see the picture over here, you can see there are three knobs over here, or we can see three connections that is common. So the common is for, we can say, for the ground potential. If you have to measure the voltage, then the positive is given to the voltage and the one is given to the common. And when you have to measure the current, then you have to connect a knob in the current. In this knob you can connect the knob for the current measurement and another one is for the common. So you can see the ranges over here. So this side, that is V, like this shows the DC measurement, and the right side like this shows the AC measurement, and this is the middle position of the knob. So here how can you measure the voltages and the current over here? If you have to measure the voltage, then you have to connect a positive knob to the volt at this position and the negative to the common, and you can measure the voltages and the resistances over here. The green you can show here at this DC side. So this green color shows that you can measure the resistances over here. So to measure the resistance and the voltages, you have to put a connecting wire at this V ohm knob and another to the common knob. So in that what you have to do is, when you have to measure the voltages, you have to keep this middle knob at this, whatever the white color ranges these are shown, that is for the DC voltage. So when you have to measure the voltages, you can keep this knob at this white ranges and you can measure the DC voltage. Now if you have to measure the resistances, then you will keep this knob at this green color ranges where you can measure the resistances over here. So this is all related to the DC voltage and the resistance measurement. Now if suppose I have to measure the current, then how I am going to measure the current is, for the measurement of current, you just have to remove the wire from this voltage terminal and you have to connect it to the ammeter terminal, and the common is remaining at that position only. So when you are removing the wire from this side and connect it to the ammeter side, then you can measure the current over there. So that current can be DC or AC. So if this knob is at the left side, then you are measuring the DC current, and when this knob is at the right side, you are measuring the AC currents. So this is related to the measurement of the voltage and the current and the resistances in the multimeter. Now another thing you can see over here, this is HFE. So what is this portion requires? So this portion gives you the device testing. If suppose we have to test a device like transistor or diode or the HFE parameter of a transistor, we can measure those parameters at these positions. We can connect our diode or transistor in these, and we can measure the H parameters of the transistors, and we can test the devices whether they are in a working conditions or not. Which devices? Like diodes and the transistors. Now what are multimeters? Multimeters can measure the voltage, current and the resistances. And some multimeters also have a continuity check and the diode check. Like this multimeter which is shown in the picture, we can say here at this portion we can check the continuity of the diode, or we can say we can test the diodes or the transistors over here. Now how to make the continuity test? This is a setting used to check if two things are electrically connected. So what is continuity check? Continuity check is done for two things which are electrically connected or not. So for this purpose, the continuity check is done. The multimeter will beep if there is a conductive path between two probe tips, and will not make any noise if there is no conductive path. So how we have to check the continuity test? We can see the continuity test when the multimeter will beep, and when it beeps we can say that there is an electrical path present between the two probes of the tip, and if there is no sound from the multimeter we can say there is no conductive path. Now what is diode check or the transistor check? This function is used to test a diode, which is like a one-way valve for the electricity. It is not lets current flow in one direction. The exact function of the diode check can be different on the different multimeter. So if we have to check the diode on the multimeter, how we can check the diode? So this is the symbol for the diode, and we know this is anode and this is cathode. So when we can say diode it is in working condition or it is working, we can say when we can have the voltage of 0.6 to 0.7 volt. When it shows the voltage between anode to cathode from the range 0.6 to 0.7 volt, we can say diode it is in the working condition. Now suppose if I have to measure the transistor at the multimeter, how can I say that transistor is working or not? So in the transistor we are having three terminals like base, collector and emitter. So we know this transistor consists of combination of two diodes. So in this NPN transistor, the two diodes are NP and PN, which are internally connected. So I have to check whether this transistor is working or not on the multimeter. So what I have to do is I can connect two probes between this base and the emitter terminals. Now why I have to connect the terminals to the base and the emitter only? Because in the base and the emitter junction is nothing but the NP junction, and we know this NP is nothing but the diode. So this should shows us the voltage of 0.6 to 0.7 volt, and when it is showing us the voltage from 0.6 to 0.7 volt, we can say transistor is working. That is, transistor should be forward bias when it shows the voltage between 0.6 to 0.7 volt. And if it does not show any voltage between base and the emitter junction, then we can say transistor it is not working. So this is how we can check or we can test the diode and the transistors on the multimeter. So we have seen about the multimeter, how to test the transistors and the diodes on the multimeter, and how we can measure the AC and the DC quantities on the multimeter. So first what we have seen if we have to measure the resistance, which type of electromagnetic sensors we are using. Now if we have to measure the current, let us focus on the electrical current sensors. So what are the electrical current sensors? A current sensor, it is a device that detects the electric current, that is AC or DC, in a wire and generates the signal proportional to it. So what is the basic work of this electrical current sensor? Basically, the electrical current sensor detects the electrical current and generates a signal which is proportional to the current. In voltage sensors, what is happening? The signal is proportional to the generated voltage. In electrical current sensors, the signal generated is proportional to the current. So the generated signal could be analog voltage or current or even digital output. As I told you, we can measure AC or DC current in the current sensors, and the generated signal is proportional to the current which is measured, and the generated signal can be analog voltage or current or even a digital output. So we can say that that can be the analog signal or the digital signal. It can be then utilized to display the measured current in an ammeter and can be stored for the further analysis for the data acquisition system and can be utilized for the control purposes. So how these current sensors are differentiated or how it can be divided? The sensed current and the output signal can be. Now I told you we can measure the AC quantities as well as the DC quantities. If there is a alternating current input, that is AC input, so the sensed current and the output signal can be, first it can be a alternating current input. So if there is a alternating current input, there is an analog output which duplicates the wave shape of the sensed current. Because we are giving the AC current, so what will be the output? So this is the input, it is AC we are giving. So in the analog output, it duplicates the wave shape of the sensed current. Duplicate means we are getting the same kind of waveform in the output for the alternating current input. So this is the first condition. In the second, what we have to do is bipolar output, which duplicates the wave shape of the sensed current. So this is the analog output, this is bipolar output, and third one, which it can give us unipolar output, which is proportional to the average or the RMS values of the sensed current. So if we are giving the alternating current as an input, output we are getting three different types. Analog output, in which the input and the output are duplicate of each other. In the bipolar output, when the alternating current as an input we are giving, the wave shape of the sensed current, and the unipolar output where it is proportional to the average or the RMS values of the sensed current. So first condition what we have seen, when we are giving the alternating current as an input. In the second condition, what we have to see, when we are giving the direct current input. So for the direct current input, we are getting two types of the output, that is unipolar, in which with the unipolar output which duplicates the wave shape of the sensed current, and the digital output. In the digital output, which switches when the sensed current exceeds the certain threshold, then it is giving us the digital output. Now this current meter is based on the working principle of the galvanometer, the basic principle of the galvanometer. First of all, let us see what is galvanometer. Galvanometer, it is an electromechanical instrument which is used for detecting and the indicating of the electric current. So what is galvanometer? It is an electromechanical instrument used for detecting and indicating an electric current. What is electromechanical instrument? Electromechanical instrument means electric current or the electric signal is converted into the mechanical one, that is called as electromechanical instrument. And this galvanometer is used for the ammeter measurement, for the ammeter instruments where we have to measure the or where we have to sense the current. So it works as an actuator. Actually, this galvanometer can act as a actuator. So how does this works as actuator? it works as actuator by producing the rotary deflection in the response to the electric current. So in the galvanometer, when the electric current flows, it produces the rotary deflection in response to the electric current. Electric current flowing through the coil in the constant magnetic field. So we can see here the diagram for the moving coil galvanometer. So in this moving coil galvanometer, you can see here, this is north and the south pole of the permanent magnet. This is moving coil. The yellow color which can shows us the moving coil, and this red color shows us the iron core. This is mirror. In that mirror you can see the deflection of the coil, and it is connected to the lower suspension. These are the magnetic permanent magnets. This is upper suspension, iron core, and these are the north and the south pole of the permanent magnet. So how does it work? The galvanometer is a type of ammeter. It is an instrument for detecting and the measuring of the electric current. So it is an analog electromechanical transducer. Again, it is a transducer which can convert one form of energy into the another one. Which type of energy? Electromechanical. That means electrical signal is converted into the mechanical energy. How? It produces the rotary deflection through a limited arc in response to the electric current flowing through its coil. So the potentiometer is based on the premise that the current sustaining coil is kept between the magnetic field experiences the torque. Now let us see where is the magnetic field produces. So in this diagram you can see these are the permanent coil and this is the moving coil. So here where the magnetic field is produced between the coil and the permanent magnet, the rotary deflection of this moving coil is done, and that rotary deflection shows us the reading for the current sense, and that current is proportional to the, or we can say the deflection of coil is proportional to the current which is produced in the coil between the magnetic core of the permanent magnet. So what is this moving coil? The moving coil, it is a current carrying part of the galvanometer. It is a rectangular or circular, and it has number of turns of fine copper wire. So it has fine copper wire turns so that it can senses the current, so that its deflection can be proportional to the current which is flowing through the coil. The coil is freely moved about its vertical axis of the symmetry between the poles of the permanent magnet. The iron core provides the low reluctance path. Why it provides the low reluctance path? For the maximum current, and hence provides the strong magnetic field for the coil movement. Now we have seen in the diagram there is a suspension. As you can see here, the upper suspension and the lower suspension. Now what is the use of this upper suspension and the lower suspension? Let us see. The suspension is used, the coil is suspended by the flat ribbon which carries the current to the coil. So suspension is used for carrying the current to the coil. The other current carrying coil is lower suspension whose torque effect is negligible. So we have seen there is a upper suspension and the lower suspension. So what is the use of suspension? The coil is suspended by a flat ribbon which carries the current to the coil. Suspension carries current to the coil, and lower suspension is used. Lower suspension is whose torque effect is negligible. The upper suspension coil is made up of gold or the copper, which is made in the form of the ribbon. So the upper suspension coil is made up of gold or the copper to produce the maximum current or to carry the maximum current. The mechanical strength of the wire is not very strong. and hence the galvanometer handle carefully without any jerk. Why we have to handle it very carefully? Because the mechanical strength of the wire is not very strong, hence we have to handle the galvanometers very carefully. Then we have seen in the constructional diagram that there is a mirror. Now what is the use of mirror? The suspension carries a small mirror which casts the beam of the light, and the beam of the light placed on the scale on which the deflection is measured. So what is the use of mirror? The beam of the light is placed on the scale which the deflection is measured. Then there is a torsion head. What is the use of torsion head? It is used for controlling the position of coil and for adjusting the zero setting. Torsion head is used for controlling the position of the coil. Now why we need to control the position of coil? Because for the accurate measurement, for the greater accuracy, we should need to control the position of the coil and for adjusting the zero setting. Now let us see how the galvanometer is converted into the ammeter. We have seen the constructional diagram for the ammeter, and we have seen how the moving coil is used for the sensing of the current and how it shows the current reading. Now let us see how the galvanometer is converted into the ammeter. Galvanometer can be used as an ammeter by connecting the low resistance wire in parallel with the galvanometer. The potential difference between the voltage and the shunt resistance are equal. How we are going to convert the galvanometer into the ammeter? In this, the potential difference between the voltage and the shunt resistance are equal. So you can see the diagram, simple diagram over here. This is the galvanometer and the resistance, it is connected in parallel with the galvanometer. How it is connected to the ammeter? That galvanometer should be connected with the resistance, and when the galvanometer is connected with the resistance, it works as an ammeter, and the potential difference between voltage and the shunt resistance are equal. So what we have to measure here? We have to measure the voltage across galvanometer. So voltage across galvanometer can be given as galvanometer resistance G and the galvanometer current Ig. So the voltage across shunt resistance is Vs, which is equals to S into Is. Now because we have to convert that galvanometer into ammeter, we have to find out the shunt current. So the shunt current Is is given by I minus Is. This Vg equals to Vs. What is this G? G is the galvanometer resistance. Ig is the galvanometer current, which is equals to the S into Is. So basically we can get this equation, S is equal to G, that is galvanometer resistance, into galvanometer current divided by I minus Is. So this is how we have converted this galvanometer into the ammeter. So this is how we have converted galvanometer into ammeter. Now let us see what are the applications of the galvanometer. So there are different types of the applications of galvanometer. It is used for detecting the direction of the current flows in it. It also determines the null point of the circuit. As we have seen in the constructional diagram of the galvanometer, that galvanometer should adjust to the zero position for accuracy. So it determines the null position of the circuit. The null point means the situation in which no current flows through the circuit. So what is null point? It is the situation in which no current flows. So it is used for the detection of the and the direction of the current flows through the circuit. It is used for the measurement of the current. So the voltage between any 2 points of the circuit is also determined through the galvanometer. That means galvanometer can be used for the measurement of current and it can be used for the measurement of the voltage. Now let us focus on the ammeter. We have seen how the galvanometer is converted into the ammeter. When we are connecting a resistance parallel with the galvanometer can be converted into the ammeter. Now let us focus on the ammeter. What is ammeter? As you can see the picture over here, this is the ammeter, picture of the ammeter. Here you can see the needle over here, and these are the ranges given for the different ranges of the current. And this needle shows the different readings for the current. So what is ammeter? What is basic definition of ammeter? Ammeter is ampere meter. Ampere meter means because we are measuring the current in the amperes, so that is why it is called as ampere meter, which measures the ampere value. Why? Because ampere, it is the unit of the current. So ammeter is a meter or instrument which measures the current. Now let us see the working principle of an ammeter. So the main principle of ammeter is that it must have a low resistance and also inductive reactance. So first point is it must have low resistance and also inductive reactance, low inductive reactance and low resistance, because it is an ammeter which shows us or which measures the values of the current. It also has the low impedance because it must have very low amount of voltage drop across it. So in the ammeter it must have low resistances and it must have the low voltage drop across it. So there are two basic requirements, that is low resistance and the low voltage drop across it. And it must be connected in series connection because current is same in the series circuit. So this is very basic point, as we know that ammeter should be connected in series because the current is same in the series. Also due to very low impedance, the power loss will be low. Because ammeter is connected in series and it must have the low resistance. So if it is having low resistances, then the power loss will be less, and if it is connected in parallel, it becomes almost a short circuit path, and all the current will flow through the ammeter as a result of high current and the instrument may burn. So what is happening when we are connecting ammeter in series and when we are connecting ammeter in a parallel? In series, when we are connecting ammeter, the current is same and current is divided into the branches. So your instrument will not get harm. But when the ammeter is connected in parallel, it produces the short circuit path and it produces the high current which can damage your device. So that is why ammeter is always connected in a series. So you can see this is the symbol for the ammeter. This is the symbolic representation of the ammeter. So ammeter is connected in series with the circuit. It has low resistance, and when it is having the low resistance, it is having small voltage drop. And why we should keep the resistance value should be low? Because it measures the current which passes through the circuit, and when it measures the current which is passing through the circuit, when the resistance is low, then it produces the voltage drop which is very low.